Okay, 1 through 6. We are on page 419, 1 through 6. Do you have questions 1 through 6? Bookwork, okay. 1C or 1D? Okay. D and C or no? Okay. All right. Remember, guys, we're on this circular plane. Yep. Thank you. We're on this circular plane, but at the same time, we have these cross sections that are coming out of it, right? Three-dimensionally. Do I need to put? I can't really draw these as well. But this equation is, of course, your x squared plus y squared equals 1. Well, what we graphed was the square root of 1 minus x squared and negative square root of 1 minus x squared. Are y'all remembering this? All right, so this is 1C. We'll do C first, then we'll move into D. All right, so this said the cross sections are squares, but they're not just any squares, because this is not the side length of the square. This is actually the length of the diagonal of the square. So what is the diagonal of a square? So that's important to know. I agree. I am not good at drawing it three-dimensionally. A diagonal of a square is here. So you put that little diagonal on the x. Yeah. Well, on the, if you've got this circle, right, the diagonal stretches from on the edges of the circle. It sits perpendicular to the x-axis. So it would make, if this is the x-axis, the diagonal sits perpendicular to it. Okay, it's not on the x-axis like this, it's on it like this. Does that make more sense? Okay. So like you can pick up each triangle. Right. Think about it. So, right, the top half is a triangle, the bottom half is a triangle. So it's like a triangle coming out the top and a triangle coming out the bottom. Yes, because it's the whole square. So that whole slice of bread coming out is a square that's turned on its side. That's why it has to be two. Right. So this diagonal length is twice this length, right? So this, well, first I got to find, it says the length of a square's diagonal is square root of 2 times the length of its sides. Okay, so here, this length would be 2 of these, right? No, we're just working through a problem. If you said the diagonal was square root, the length of a square's diagonal is square root of 2 times the length of its side. So to get from here to here, you multiply by square root of 2. But I got to go backwards, not forwards. So how do you know that? Okay, so what is the length? Remember, this is the diagonal of the square, right? Okay, but ignore that right now. Right now, let's look at the length of the diagonal. Because the diagonal is stretching across this circle, right? We agree that this is the diagonal. That is that. Yeah. Okay, this is 1C. Okay. This distance from the x-axis to here, because from the x-axis to any point, it's the square root, right? But it's doubled because there's 2 of them, because it spans the whole thing, not just one. So that's why it's 2 times. So you're like separate problems. You don't relate that to the other. No, that's correct. That's correct. Now, because the area of a square is side times side, right? I've got to make my way back to here. So now I don't even worry about this anymore. Now I'm worried here. Okay? Right now I don't have to worry about that circle and about lengths, anything like that. Now I'm just looking at the square. If I have a square, so this is a 45, 45, 90 triangle, and they told you in here what to do. But if they didn't tell you what to do, you would know that this is a 45, 45, 90 triangle. And with a 45, 45, 90 triangle, the sides are the same. Whatever this is times the square root of 2. Always. Remember, there's two special triangles, 30, 60, 90, 45, 45, 90. This is the 45, 45, 90. You had to do the 30, 60, 90 in part D. All right, but if I multiply by the square root of 2 to get to the hypotenuse, how do I get from the hypotenuse to the leg? You divide, you do the opposite, right? So to get here, this would be 2 times the square root of 1 minus x squared divided by the square root of 2. Are y'all with me? So what is the area of 1 square? If this is the side, this is the same thing, right? That's right. That's right. So it's this squared. Right? Are y'all with me? Which would be, when I'm multiplying, as long as I'm not adding or subtracting, I can just take that squared to everything, right? So this becomes 4 times 1 minus x squared over 2. Because area of the square is the side times the side, and since they're the same, I just square the side, or side squared. So the area of a square is 2 1 minus x squared. And that's all you had to do for that one. You didn't have to go any further. You didn't have to do anything. You didn't have to actually find the volume. They just wanted you, how do you find the area of one of those shapes? All you had to do. Okay? Let me know when you're here. 6, let me know. Text me. Part D says the cross sections are equilateral triangles. I think it's easier to see this one in their picture, as it's hard for me to draw, but this equilateral triangle is coming out of the top of it's slices of triangle. But it says that the base of the equilateral triangle sits on the plane. So in other words, if I've got this equilateral triangle, all sides are the same, part D, this is the base of the triangle. We already know that length. We know what the length that spans across is from one end of the circle to the other. What is it? 2 times the square root of 1 minus x squared. Because from the x-axis here is the square root of 1 minus x squared. But I got to double it to get both pieces, both parts. How do I find the area of a triangle? 1/2 base times height. I have the base, I'm missing the height, you agree. That's what I need. How am I going to find it? This is a 30, 60, 90 triangle and a 30, 60, 90. And y'all, I would make sure you memorize these special rights because they do show up a lot. What do you mean ones? Yeah. Like, and then you make that one a half, or the other one a half. Like, I feel like that's even like that, man. Like, you make that one like 1x, and you make the other side a half x, and then you make the other. Oh, you can, yeah, yeah. Like, what's the missing side? If you ever can start with the short leg, it's easy to find everything else. So it's just, this height is going to be the square root of 3 times the square root of 1 minus x squared. Right? And that's what we were looking for. We were looking for that height. Yes? So this triangle is, the base of it is inscribed in the circle. So you can put them both under the same square root if you want to, because you can multiply radicals. So you could do this as 3 times 1 minus x squared, which would be 3 minus 3, or leave it like that. It doesn't matter. All right, but the point is that I need to find the area of this. So the area would be 1/2 the base to square root 1 minus x squared. The height, of course, is this. 3, 1 minus x squared. Well, if I left this, the 2's cancel, yes. If I had left that as the square root of 3 times the square root of 1 minus x squared, since those are the same, the radical could go away. So it'd be the square root of 3 times 1 minus x squared. Remember, you're just looking for area. We're not even integrating now. We're just looking for the area formula.
The area was 1/2 square root of 1 minus square root of 3.
Yes. All right, so 1 through 6 are okay then in the. So, okay. Did y'all have 7 through? I thought I did 1 through 6.
Yeah, I haven't started on that time. This 1 through 6.
Okay, yeah. So I'm looking at the book right. Y'all talking about 6 in the book or 6 in the packet? Oh. So y'all are good on book. The 1 through 6 book.
I mean, I'm all right.
Y'all can find the volume. I feel like we should do one of them. Okay, let's do. I don't know which one y'all. They're the same equations. Let's do number 4. 4 is a little different. Okay. The solid lies between the planes perpendicular to the x-axis and x equals -1 and x equals 1. The cross sections perpendicular to the x-axis are circular disc whose diameters run from the parabola y equals. Okay, so let me. Bless you. All right, so I've got 2 parabolas here. I've got y equals x squared and what, bless you, 2 minus x squared. 2 minus x squared. So let's just graph these real quick. We're doing this in Algebra 2 right now. They love it. All right, so x squared is just going to be your parent parabola here, right? Parent graph. And the other one is up 2 and reflected down. That's exactly right. So up 2, let me do it in a different color so you can see. Up 2 and then down So this is 2 minus x squared. So what they're saying is they gave you the -1 and the 1 because I'm assuming that's these points where they intersect. And it says that the cross sections perpendicular are circular discs whose diameter run from the parabola to one parabola to the other. So I'm looking at a circle, and this is the diameter of the circle. Well, you'll pull cross sections of circles out.
So they look more like elongated ovals or circles?
They'll be circles. They'll be actual circles, but the diameter changes each time. That's what's changing each time is the diameter, but it's still a circle coming out. So my first question, and this is the hardest part, and that's why you had to do this to start with, is I need to find the area of one single circle with respect to x. So how do I find this length? No, you're not. Not area yet. I'm just looking at the length. So this length right here.
When it's circle, it was square with one x squared.
You got two different functions. Let me ask you this. What is the distance from here to the x-axis? If I went down to here, what's that distance?
The y value.
That's the y value. It's 2 minus x squared, and you're exactly right. Right. Now you're thinking. This is 2 minus x squared.
So the y value minus the y.
That's exactly right. But I'm going to have to take out this little piece. So what is that little piece? Of x squared. So this whole thing, that's right, 2 minus x squared minus x squared. That's the diameter. Do we agree? Does everybody see where I got that? So the diameter, the diameter here is 2 minus 2x squared. Are we all in agreement? If that's the diameter, what's the radius? Half of the diameter. So if you cut that in half, so if you divided all this by 2. How do you find the area of a circle? Pi r squared. This is the radius. So the area of one of my circular cross sections would be pi times r squared. Now, to find the actual volume, I have to integrate. So I'm going to do the integral. What am I going from? From what to what? -1 to 1 of pi times 1 minus x squared dx. If this was a calculator problem, I would plug it in now. It's not a calculator problem. So what I'm going to do is -1 to 1, I'm going to pull the pi out. I'm going to FOIL this out. So I have 1 minus 2x squared plus x to the 4th, so that my antiderivative is easy for me to find. So do it. Okay. I've got x minus 2/3 x cubed plus 1/5 x to the 5th from -1 to 1. The reason it's it is recording. Number 5 on the area. It says it's bounded by the graph x equals log y. X equals 2, y equals 1, and y equals 2. Agree or disagree? This is number 5. Then I can just graph. Got what? Oh my gosh. Got an asymptote at 0. It's a growth graph that goes through 1. So this is e to the x. Then you got y equals 1. Y equals 2. What is wrong with them? And x equals 2. I need another color. Y'all get your butts back in here. What is wrong with y'all? I'm gonna, where does 2, what's, I don't have my calculator. Where does 2 fall here? E to the second would be like 3, which would be like 9. I know, I'm thinking where the 2 is gonna fall. The 2 is gonna fall somewhere over here. So let R be the region bounded by the graph. Da, 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 da. So if it's got to be bounded by all, it's going to be this area. Is that what you said? Guys, pass. It's going to fall over here. So now where are we bounded? So this is the area. Got to be. Right? That's the only one that's bounded by everything. So if I'm doing this with respect to y, I'm going from 1 to 2. This is my function, and this is my function, because it's what x equals. This is just telling me my bounds. So I'm going from 1 to 2, and I'm going to do rightmost 2 minus log y dy. You don't have to evaluate it. Yes. That makes sense? What else on that packet? 7. 7, 7, 7. The base of a solid is the region bounded by the x-axis in the graph. Y equals the square root of 4 minus x squared, which you should know is a what? Oh my gosh. The square root of 4 minus x squared is what? Yes. Ooh. Terrible, but okay. You're supposed to recognize that being a semicircle. For the solid, each cross section perpendicular to the x-axis is a square. Perpendicular to the x-axis, so from here to here. This time I'm not going all the way through the circle. This is just a semicircle, right? So it's bounded by the x-axis and the graph. For the solid, each cross-section perpendicular to the x-axis is a square. Set up an integral expression that gives the volume of the solid, and then calculate the volume of the solid. So to find the volume of the solid, I need the area of the cross-section. So the area of the square that is being pulled out, side squared. So I need to know side. Do you see why it's not 2 times 4 minus x squared this time? It's just a semicircle. It's a half a circle. It's just 1. If it went here, that's when I would need to double it for the whole length of the square. But it doesn't. This one says it's bounded by the x-axis in the graph. So now for the volume, what do I do? From what to what? -2 to 2. This is one of those you could use symmetry if you wanted to go from 0 to 2 and then double it. Doesn't matter. 4x minus 1/3 x cubed evaluated from -2 to 2. 8 minus 8/3 minus, and then -8 plus 8/3, right? 16, -8/3 minus 8/3 minus 16/3. Well, 16 times 3, 32 plus 16 would be 48. 48 minus 16, 32 over 3. So what y'all got? I know. Give me a little bit harder one, because I feel like after I work one or two of these, that'll leave you, because I know y'all did not finish these 11. This is a calculator when they gave you the graph, which was nice. It says, let Q be the region in the first quadrant bounded by the graph of y equals cosine 3 pi over 2x and y equals x squared as shown to the right. Well, that was nice of you people. Here's one piece, especially since this is calculator. This is my region I'm looking at. The region Q is the base of a solid with cross sections perpendicular to the x-axis, is an isosceles right triangle with a leg in the region. Okay. Let's break it down then. First of all, an isosceles right triangle means two sides are the same, and if it's a right triangle, that means it's a 45, 45, 90 triangle. Isosceles right. Two sides are the same. Right triangles 90 degrees. And it says the leg is in the region, and it says the base of the solid has cross sections that are perpendicular to the x-axis. So this has to be what we're talking about. Now we could turn it this way and do it with respect to y, which we will get to some like that, but we're not quite there. But since it's perpendicular to the x-axis, I am doing it with respect to x. So now my question becomes, what is that length? Because to find the area of, remember, I'm constantly looking for the area of the cross section. So the area of the triangle here, 1/2 base times height, right? You agree? With an isosceles right triangle, that means it's 1/2 one of these legs squared, right? Because this is base and this is height. Agreed? Does that make sense? Yes. So all I need to do is find this and square it, and that will be, so the area of a triangle is 1/2 base times height, right? If I let this be the base, my height always drops down at 90 degrees. So that would be my height. But because it's an isosceles triangle, right? So they're going to be the same. All right, how do I find that? This is 2x squared. I know that because it's a parabola. So this must be my cosine 3 pi x over 2. What do I do? How do I find it? Yes, exactly right. The top one minus the bottom one, right? Because it's got to work anywhere around. So from here down would be cosine 3 pi x over 2. From here down would be 2x squared. So if I take the whole thing and subtract out the piece, it's not. Cosine 3 pi x over 2 minus 2x squared. But we got to square it, right? The area of my triangle is going to be 1/2 all of this. Remember, this is a calculator problem, so don't look at this and let it intimidate you. I wouldn't do any more work with it than what I had to do, because I would now integrate. But before I integrate, I need to know my bounds of my. I need to know the bounds. I know I start at 0, right? But I need to know this point. You set them equal to each other. And since this is a calculator problem, I'm going to graph them both, and I'm going to calculate the intersection, which is, I don't know. I don't have my calculator. I don't have the answer key for this either. So somebody graph it and tell me where they intersect. What is it? $295 what?
295,964.
Okay, I'm gonna leave it there. I'll make it 296. So I'm gonna go from 0.296 of my area. You can. I would put this straight in my calculator though. I would put this in my calculator and then integrate or graph it and do the integral, whatever you like to do best, but I would use my calculator to find that integral.
How does it go again?
What do you mean? So you got to put it in y equals regardless. Right. And then you can go math, FN, INT, y1. So you go y variables, you know what I'm talking about? So y1 comma, and then you do the variable that you're integrating with respect to. So you do x, and then comma, and then you do your lower bound and then your upper bound. You would have to change, you would have to put in your equation differently. You would have to put it in, like your equation would have to be with the y's in it.
I wanted to put it in my calculator, but I was doing
I'm pretty sure you can change your mode. I'll look at it for you. I'll look at it for you. Okay.
I was about to just graph it.
Did you?
I was about to just graph it with X and turn my calculator. That would work.
Yeah.
I'm gonna check it on my calculator
With respect to y. Yeah. All right. Are y'all okay on this? Lower bound first. The washer method of this. But it's still easier than cross sections. But we'll just do the disc method today. Monday we will do the washer method. Tuesday we will review and pull everything together is what I'm thinking. And then Wednesday you won't be here. But I'm thinking you should be ready for a test by Thursday. But I will make that decision. It might be. Shut up, Dylan. Yes, you will. Okay. All right, the difference in these is when we're doing cross sections, we're thinking about a three-dimensional shape that sits and follows a curve. Like, have y'all ever seen those puzzle balls? It's like a wooden ball that has pieces that like come out of it. That's what I think about when I think about cross sections of solids too. And so you got all these different shapes that you can come out, that you can. Why? Here's what a solid of revolution is. We're given a region, we're given a graph. So let's say, and I'm just going to use the example out of your book. 2 plus x times the cosine of x. This would definitely be a calculator problem. Well, maybe not. Maybe you wouldn't even need it. But if you graph this, and then it says that over the interval from -2 to 2. So if you were to graph this, it looks something like this. Okay. So now what we're going to do is we're going to imagine that this piece, what? Nah, Russell gets every month this year. Okay. Imagine, if you would, that this piece rotates around the x-axis back on itself. So the football I keep talking about, have y'all ever seen those? Probably in elementary school. They're shapes. This was a football all smushed together, but you could open it up and it rotates around, and then it's a three-dimensional football. Yes, on the inside. So it's like this, and then it. Yes. Okay. So that is the concept behind volumes of rotation. I will. But imagine, if you would, this one-dimensional piece of paper. This is the x-axis. It rotates around and creates a three-dimensional shape. Okay, so it looks like a three-dimensional vase once it's rotated around. Okay, are you following what I'm saying? So each piece I take out of this is always going to be a what? A circle. It's going to be a circle every time. In fact, all of these are all volumes of rotation are circles because they're making a circular pattern around. They're rotating about the x-axis. So that's why this is easier, is because it's rotating around all the way around. So then if you take a football and you cut a slice out of it, the slice is always going to be a circle. Are you following? You're not following.
You mean like if I cut one of those things in half? No, yeah. Like this is a football. Yeah. I thought you were like.
Okay, all of these, like, look at this. If you've got the square root of x squared and you circle it around, it comes out almost like a bell, but still, any place you cut it here, it's going to be a circle. A sliver of it, yes, like that. No, you're cutting it perpendicular to the x-axis. Okay, so if I want to know the volume of the solid created by the revolution here, I'm going back to the cross-section thing that we've been doing, but the difference is this time I'm not talking about squares and triangles and everything else. It's always a circle. That's what I was saying, so this is easy. So this is a piece of paper. It looked like a vase. It almost looked like this three-dimensional vase that comes up. I don't know, something like that maybe. Okay, yeah. I don't. Oh my gosh. Okay. So my question is, what's the volume of this vase shape that we've got that's bounded by this curve? Right? So all I need, because I know I need the area, right? The area of the circle, which is pi r squared, I need r. Well, what is r going to be? It's the y, right? 2 plus x cosine x squared. Isn't that going to be the same every time, though? Isn't it? This length is still 2 plus x cosine x. And so is the next one, and the next one, and the next one. X is varying. So, right, yes. So to find the volume, I'm going to do the same that I was doing when I was doing cross sections. I'm going to go from -2 to 2. And this is where I'm doing the area of the circle. So it's I agree. Oh my gosh. Calculator problem for sure. Okay, so I'd use this to integrate and I would find out that it is approximately. I told you I think this is easier. It is. Now, you will have some that are with respect to y instead of with respect to x, but it's the same process. Yes. Just so that you can get excited about Monday. Monday is washer method, so it'll be enclosed by 2 curves, so maybe there's another one here. So whenever it does it, if you rotate it around, there's a hole in the middle because I only want this. So there's a hole in the middle, so I have to subtract, and they call it washer method because each piece that you cut out looks like a washer because there's a hole in the middle of it.
The part you don't want by pi r squared, and then the part you do want by pi r squared.
Subtract them. That's exactly right.
So are you finding the integral area in the middle? Or are you finding
Depends on how it defines it and what it wants you to find. It's always easiest if it sits on the x-axis and is bounded by the x-axis there, and you're rotating around and it's a solid like that, than it is if it's. Yeah. All right, let's do an example.
Why don't I get a month? How do I have every month?
52.49.
How do I have every month? I gotta hear it.
Don't follow him up. Don't even say anything. Y'all don't start this in here. Yeah, y'all save it for Coach Hendricks. He can't wait to hear y'all's arguments.
I get 11 and a half.
Okay. I'm going to do one about the y-axis. Gosh.
Honestly, they should make a male month. I mean, that would work.
You have a picture for number 8. Now you're hitting on the right thing. No, I'm just kidding. Okay, so this says, find the volume of the solid generated by revolving the shaded region about the given axis. So this one says about the y-axis. So you don't have a choice but to do it with respect to x. Okay? Yes, that's exactly what it says. So can you visualize what that shape looks like? It's a funnel. That's exactly right. Yeah, a cone or a funnel. That's exactly right. Y'all are doing so good with this. I'm impressed. It's a cone, yeah. You're rotating that blue all the way around 360 degrees to form a solid. So if I'm doing this with respect to y, that means my bounds are going to be from 0 to what? 2. Now I need to know what the radius, because it's pi r squared, right? So what is r?
Isn't the radius the 3y over 2?
Isn't it what?
Isn't 3y over 2 radius?
Okay, so yes, this is 3y over 2 because I'm with respect to y this time, right? And that is half of my circle's diameter because whenever it loops all the way around, that'll be half of it, right? So it's, nope, you don't have to times it by 2 squared pi. Because, okay, if you've got a cone, right? And yeah, every single time it's pi r squared. Well, this is with respect to y. Well, I'm glad y'all think so. It is. That's why I said cross sections are a little harder. Okay, I'm just gonna give you your stuff because I've lost half of y'all anyway. 6 pi. So yes, this would be. So that's 9y squared over 4. That would be 3. So divided by 3 would be 9 over 12 y cubed from 0 to 2. What are y'all doing? Y'all shut up. Whatever y'all doing, shut up. Because it ain't even, I'm sure it's not appropriate, whatever it is. And I don't even know what it is. If I plug in a 2, 2 to the third is what? Come on, calculus, 2 to the third. I don't have to do the 0 because 2 to the 0 is 0. Let's see. 4 and 4 goes into that 2 times, goes into that 3 times. That becomes 3 times 2, 6 pi. Yes.
Do you believe that Asians should have a mark?
Okay.